So the title, the silicon, a plant beneficial nutrient for horticulture crops, and it is one of my the research area. Even though when I was at University of New Hampshire, and in my current university, it's also one of the research program. We are working with the silicon in the fruit crops and different stresses, heat, cold, and in particular the shelf life. So okay. So in this talk, I will give you the introduction about the silicon, some its benefits, what are its different sources, application methods, and what's the research I am engaged with related to silicon. So silicon is not a new element. It is the like abundant element on the earth crust, like after oxygen, which is 49.2% after oxygen. Silicon occupied the second position, and which is mostly in the form of silicon dioxide, SiO2. So, and there are two terms are used, and the silicon and silicon. So basically, the element we are talking about, it's a ortho-salicylic acid or monosalicylic acid, which is the form plants can uptake. So the other thing that's silicon, that's the difference is just the end of the E. That's a polymer, and it is being made up by combining silicon, carbon, hydrogen, and oxygen, and it's very common we use in our houseware as an adhesive, and that's not a thing like you're gonna be used and apply to the plants. Don't gonna seize the stomata of your plants. So the upper one, silicon, the monosalicylic acid or ortho-salicylic acid, this is the only form which is H4 SiO4 which plants can uptake. The concentration of silicon, it varies from in the plant tissues, it's from 0.1 to 10% on dry weight basis. And overall, the monocots has accumulate the high amount of silicon as compared to the dicots. And it started from the legumes and maximum in the grain crops. But the concentration in the varies from different from roots, leaves, and shoots, and most of the amount we is accumulated in the mature leaves. This is also the common question, like either silicon is beneficial or essential. So silicon is basically is not an essential element. So what are the essential element mean? Like plants, it is 100% needed the plants to complete their life cycle. And in the absence of this, the essential element, plants cannot complete their vegetative growth and proper reproductive growth. So like the nitrogen, phosphorus, potassium, oxygen, these are all are the essential elements. But the silicon is a beneficial element, like it is not required to complete the life cycle or are not required by the to complete the vegetative or reproductive growth of the plant, but it provides you the supplemental effect. So, and it is not directly involved in any plant metabolisms. So like silicon, selenium, cobalt, these are the example of plant beneficial elements. And before, in the first time in 2012, the silicon was categorized as a plant beneficial substance or plant beneficial nutrient or element by the Association of American Plant Food Control Officials. And before 2012, there was no that kind of labels was associated with silicon. And that's the reason after 2012, once it is designated as a plant beneficial substance, a lot of products, silicon fertilizer, silicon biostimulants with different names came like emerge in the market. And no, there, if you will Google, there are hundreds of blends and liquid and powder form of silicon fertilizer, which are directly marketed as a plant beneficial or plant biostimulants. And there are also some products which are also OMRI approved, and you can use them in organic production. What's the need? What the benefit you will receive? It is a really multi-dimensional element. If you are adding it in your nutrition program, regardless so you are growing the vegetables or fruits or ornamentals, it will help to improve your yield. It will strengthen the root architecture. You will have the strong and better root system. and better fruit size, improved post-harvest life. Like in my current program, we are working a lot on using the silicon to improve the pre-harvest and post-harvest application to enhance the shelf life, like of the peaches, blueberries, blackberries, especially berries, strawberry, blueberry, blackberries. These are, they're very perishable, and the shelf life is a big challenge. And we are using different rates, pre and post harvest application, and trying to address how to improve the fruit firmness and post harvest life using the silicon. It is also provide the resistance to different insect pests and abiotic stresses. In the next coming slides, I will just show you some pictures or results of done by different researchers on different abiotic stresses. So this is also one of the slide. I will not talk much about that, but just it's Dr. Neil Matson, who is the speaker in today's one of the speaker in today's the workshop. So I hope he is going to be talk more about this. So in this, like the plants were treated with the after the finished products, they were just for 12 days in the post harvest, no irrigation, no nutrition, just the water, and you can see that after 12 days the plants are still the leaves are the turgid and they look healthy versus the non-silicon treated. You can see the yellowing and wilted leaves. So in another study, Dr. Neil Matson's the program in which the plants were not irrigated for 18 days, both silicon and non-silicon treated, and you can see that there is a lot of wilting in non-silicon treated plants under drought stress for 18 days. But once they were re-watered, the silicon treated plants were 100% recovered back as compared to the non-silicon treated one. So, and the same thing, it is also very, as I mentioned, and that's we are also observed here in we are working in the citrus and in blackberry and blueberry. It is very helping to give you the root initiation, uniform root, more roots, and strong root system. So in this study, this is the Petunia cuttings. They were treated with the 50 parts per million silicon after every 3 days for 4 weeks, and you can see the difference. This is the control plants, and this is the silicon treated plants. You can see there is a more. These are the 5 different cultivars, and all the cultivars responded well. If you will compare here, like a peach bowl, there is not much of the roots, but in the silicon treated, you can see there is you can see the more roots. Same in case of pink bell. So overall, in this results in this study, they have found that about 18 to 28% of the number of roots has been increased, and the root length about 25 to 35% root length has been increased. This is another example in the plug production, the broccoli and cauliflower, tomato and zinnia. Yeah, the right one is the non-silicon treated substrate, and this is a silicon treated substrate. You can see the differences in the silicon treated plants. The plugs, you can see the more roots in the cauliflower, in broccoli and zinnia. So this is the way it helps you to give the strong root architecture, and overall like 20 to 40% more root improvement. This is another study in which you can African marigold and French marigold and cucumber, the no silicon, just conventional fertilizer and silicon supplementation. You can see how much there is a more roots, and especially at the bottom, if you will compare with the control, there is a more root formation. And here you can see in case of cucumber, when you compare with control, there's a more root formation, and the roots, you can see that it's a whole, the earth ball is covered with the roots. And this study has been done in the Oklahoma State University. One of the graduate student, they apply the potassium silicate as 300 milligram per liter, and to the sunflowers. It improved the growth, it enhanced the overall the flower size, but it also enhanced the stem diameter, and especially to about 27% of stem diameter has been increased using the silicon. And so that's the feature is very important, that it helps to reduce the lodging. It gives, especially if you are growing the cut flowers, it gives you the long and strong stalks, and it's one of the good attributes for cut flower production. It is also helpful to improve the abiotic stress tolerance. Silicon has been proved to be in enhancing the tolerance to different abiotic stresses, including salinity, drought, heat, cold, flooding, heavy metal toxicity. Jennifer, the today's speaker, she mentioned there she's also doing some work. She can also share that his research work how silicon is helpful on in reducing the heavy metal toxicity and UV radiations. In my program here, we are working in the three stresses, drought, heat, and cold, because these are the issues we are having in north side of the Florida, especially in blackberry and blueberry and citrus production. And we are having a very good results using the silicon. This is just an example. This is the work in which the plants, the seedlings were initially treated with the silicon and exposed to the salinity stress and with 100 millimole of sodium chloride and plus 100 parts per million of silicon. And you can see that the difference is the plants, the seedling, more roots, more larger plants as compared to the when they were without silicon at the same level of salinity stress. So this is the how salinity suppress the growth and how the silicon is helpful to enhance to create the resistance against the salinity stress. This is my ongoing project. In my program, in the north side of the state, citrus, fresh market citrus is a newly emerging industry. And north side of the North Florida, south of Georgia, southeastern Alabama, it is becoming a new citrus growing region. And right now we have about 7,000 acres. Maybe you are familiar or not, we are in the big threat of a disease known as citrus greening or HLB disease in the most part of the state, like a southern part of the state, which produce the 95% of Florida citrus, and especially the juice citrus. But we are losing the trees every year. We used to have produced 250 million boxes of oranges, and right now we are just producing the 16,000 the boxes. The reason is the HLB. So this is the only spot where is a no HLB, and but the cold unexpected freeze events is the big challenge for us for this region. And that's the main focus of my program. We are trying to find the varieties and approaches so that we can really, enhance the cold hardiness in citrus. And just in the last week of January, and we had a snowfall in Florida, and it was about 6 to 7 inches snow, and it has a very damaging effect. And that's the reason we are using in this study. You can see the plants were treated with the silicon with 100 parts per million for about like a 6 months. And we had a freeze event in 2022. We had a 5 consecutive day below freezing. And you can see that this is non-silicon treated and silicon treated. The plants which were non-silicon treated, they are almost killed, and the plants with silicon, they did not drop much of the leaves. They were green, and in the back, even though you can see that the growers feel how the plants are like they're all fried out. So, but still the plants came back very well with the silicon treated, gave us the fruits. And if you enter to the grove, it's not on my experimental site, it's the commercial on-farm trial. And you can, when you enter the field, you can clearly see the differences. The plants are lush green, plants are more healthy, and they are big canopies. This is another study in which the silicon is also induced a tolerance against the pH fluctuation, and all the nutrient uptake is associated with the pH. And you can see that at the optimum pH at 6, this is the tomato roots, but when added with the silicon supplementation, the root length has been increased. And the same thing, but the interesting stuff is that 9 pH, when pH is enhanced and go to the alkaline side, it limited the root formation. If you will compare pH 6 versus pH 9, but when silicon added to the nutrient solution, you can see that it promoted the root formation, which is the indication it enhanced the tolerance to increase in the pH. And here, if you will see the plants, the plant is shorter, not looking healthy, but in the silicon, when 9 pH plus we are they added the silicon, it enhanced the plant growth. And overall, like there was increase in 19% shoot length, 40% shoot diameter, shoot 45% shoot dry weight, 60% root length, and 63% root dry weight. So this is how it is also helpful to give the tolerance to any pH fluctuation in the nutrient solution. The silicon also, the ammonium toxicity is the common, especially in the the ornamental plants due to the especially in the winter when the temperature is not much high of the medium, the activities of nitrifying bacteria is reduced, and there is a more accumulation of ammonia which causes the toxicity, and these are some symptoms of the ammonium toxicity in mums and new guinea patients and tomato. And but the silicon, if supplementation is very helpful in mitigating the ammonium-induced toxicity. This is the example, a study in which it's the passion fruit seedlings, they exposed it to ammonium toxicity. This is have 7.5 micromole and no silicon, and 25 micromole high ammonium toxicity, no silicon. You can see the difference control versus the ammonium toxicity, the yelling and burning symptoms. And plus, when they at the high ammonium toxicity, the silicon was added, the plants are much greener. They are better in as compared to without silicon. And here you can see the differences. No silicon ammonium toxicity and with silicon ammonium toxicity. Overall, visually, you will not see the big difference in root, but still, if you will compare with there is a differences with the no silicon and with silicon at ammonium toxicity. This is also the study by Dr. Neil Madsen and on the heat tolerance. I will not talk more about that, but just here show you how the silicon is important in inducing the heat tolerance, like plants, petunia plants exposed to 95 Fahrenheit, and again at super high temperature with the silicon treated plants, they are showing the better, even though they are wilted, but they are still not in a bad shape as compared to the non-silicon treated one. So silicon is also like a very important and in plant disease management, and there is a program at University of Louisiana State University, Dr. Lawrence Tatanoff, and I think he is the chair of the plant pathology department. His program is fully dedicated to the using the silicon in disease control in different specialty crops and row crops. There are two type of mode of action. The first thing, when it is get absorbed, it also triggers the different metabolites and secondary metabolites within the plants, like jasmonic acid, phenylalanine. These are the enzymes which are associated with plant defense mechanism against different pathogens. But it also provides the physical barrier to the entry of the pathogens. In this graphical representation, like when you don't apply the silicon, you can see there is nothing. But when you apply the silicon, it develops a silica bilayer. And in the citrus, we are in the study we are doing on, we did the silicon electron scan electron microscopy, and we see the clear that silica bilayer on the citrus leaves. And this cuticle basically prevent the entry of the pathogens and provide the physical barrier not to the pathogens. It also provide the physical barrier to the insect pest and provide the hindrance their entry into the plant tissues. A lot of research has been done and in disease control in silicon in different vegetables, cucumber, banana, bean, cherries, chilies, against different diseases, Phytophthora, botrytis, dry rot, powdery mildew, downy mildew, pythium in Poinsettia. And especially, I would mention like it is a really very effective in powdery and downy mildew. Like it is as equal. Sometimes it works like as a fungicide. It is very effective against if you are using the right source of silicon. This is another example in disease control, Poinsettia bracket edge burn, and it's also one of the common nutritional disorder in the Pitonia, and due to the calcium deficiency, and initially calcium deficiency, high temperature, high fertilizer, the brackets develop the brown spots at the edges, and once the plants is weaker due to the high temperature or any other stresses, the botrytis take over, and then it's progresses throughout the leaf. And the calcium foliar application of calcium is recommended to prevent this disorder, but the research has been done, and which shows that the silicon is also very helpful. When I was at University of New Hampshire, I visited I think some of the grower in Maine, and they mentioned me they are already using the silicon, but their main purpose is to control the Poinsettia bracket edge burn. This is the results of a study done by McCoy and Bible. It's although it's an old study, the percentage of the incidence of bracket necrosis. So no spray, you can see how is the with the passage of time there is an increase in the incidence of the bracket edge burn. But when it's just a water spray, still it's a high. But when they start adding the silicon, you can see that with the passage of with the increase in the concentration of the silicon from 1.7, 3.5, 5.3, and 7.12, there is a significant reduction in that physiological nutritional disorder versus the control. And this is from they have started applying from days post NSAID, number of days after post NSAID. If you will say days 16 to days 47 compared with the control, there is a continuous more 4 times more increase in the incidence. In another study, the silicon found to be effective in powdery mildew in zinnia. The plants were treated with the 50 parts per million of silicon, and then they harvest the leaf and inoculate them with the pathogen. So this is the uninoculated. This is the inoculated with the pathogen and plus silicon, and this is the inoculated without silicon. And if you can see that there's a clear yellowing and disease symptoms, and you will not see much of the disease symptoms in the inoculated one and the silicon. So the plants like provided with 30 parts per million of silicon constantly, and then inoculated after 2 weeks. So silicon delayed the like a colony formation of the mildew, and it also reduced the progression of the disease. In another study, silicon was very successful in the suppressing the root and stem rot, Phytophthora stem rot on the bell pepper. So these are the non-silicon treated, and this is silicon treated under when they were not infected with the pathogen. But when they were infected with the pathogens, you can see the difference. This is the silicon treated you will not see the much of the browning in the roots, which is a indication of the disease attack, and there is not a much progression towards the stem. But in case of non-silicon treated, you can see that the roots, there is very less roots, more browning of roots, and you can see that the disease progression is more toward the stem. So that's the is the resistance and the suppression of the in the Phytophthora blight is associated with the silicon application. Same thing with the anthracnose in tomato root rot. So overall, in summary, regarding the disease, the silicon concentration increases in plant tissues, and plant as much as you will accumulate more silicon in the tissues, you will be getting the better suppression. And one thing, silicon is quite different as compared to other nutrients. First, you need to build the level of silicon within the tissues. Once they have the optimum level of silicon in the tissues, then you will have the better results. And it's not like the nutrient you will apply just one time and you will get the benefits. That we are observing in the fruit trees, that even though low, instead of 200 parts per million 3 times, maybe it would not be much effective if you are start applying 15 to 25 parts per million, but continuous application. So if you want to be the more tolerance and you want to be the active as you are you want to you plant to be more disease resistant, then continuous supply is a more important. And as I mentioned, it suppress the disease effectively as fungicide. And yes, you can also some of our pecan growers, they are mixing it with the fungicide and they are getting a more better results. So, and it has but still more research is needed on the disease side. I'm not a plant pathologist, but based on my conversation, the researchers and colleagues working on silicon, especially in say insect pests and pathogens, they are very they got a very good interesting results in the disease suppression and insect pest control. And one thing, actually, I know that I'm not a native English speaker, so I have accent. I try to I am a fast speaking person. I'm trying to speak slow. So can you get my accent? Or I'm speaking fast. Mina?
Oh yeah, no, I can understand you. I'm pretty
Okay,
good with
perfect.
accents. Yeah, and someone else in the chat says, yes, you are doing great.
Okay, perfect. Thank
I
you.
have a question for you, so I'm just waiting for the Q&A, Mohammed, and then I have a
Okay.
yeah.
Okay.
But yeah.
So thank you. The sources. So the sources of fertilizer, as I mentioned, a lot of the fertilizer after 2012 about silicon are in the market. Their main sources, some are using the wollastonite, which is a naturally occurring calcium silicate. The tuff, it's also the volcanic rock, byproducts from industrial procedures such as smelting of wollastonite and iron and magnesium, and that kind of byproducts. I know that there is a one of the in somewhere in Connecticut, there are the glass industry, they are producing that kind of byproducts and having a lot of silicon silicates of potassium and sodium. Biochar, if you are not familiar, we burn the different feedstocks like a rice husk, bamboo stick, and muscanthus grass. We burn the material at a very high temperature, more than 600 Celsius, in the absence of oxygen, and we got when the final product is a charcoal-like material. Which is used as a growing media, mix it in the soil to improve the nutrient and water holding capacity. So if you are getting the biochar from rice husk or bamboo sticks and miscanthus grass, it contains a reasonable amount of the silicon which plants can uptake. The compost, like from cattle, poultry, and swine manures, it also have some amount of silicon nanoparticles. It's a newly advanced form of silicon. The particle size is less than 100 nanometer, and diatomaceous earth, which is mostly used for soil applications. So these are different sources of silicon fertilizers. Its uptake is depending upon the soil type and plant type. Form of silicon, the solid and liquid form and application method. And most important, I will say the plant type is very critical in case of silicon. The reason is that regarding the silicon, there are two types of plant groups. So we call it silicon accumulators and silicon non-accumulator. So silicon accumulators, they for them, we don't need to like a more frequency. They can very well uptake the nutrients, the silicon, and hold it within their tissues. And but the non-silicon accumulators and mostly like the woody plants, the perennial plants, they are non-accumulator. They can uptake the silicon to up to a maximum to a certain limit. Like if you and then after that, even though you are adding the higher amounts, they are not gonna be uptake the silicon fertilizer. So the for them we are like we need to add even low dose, but more frequently, like a monthly basis. Then they will be getting the maximum benefit from the silicon. And then application method. So silicon is also what I have found in working on silicon more than 10 years. It is really very strange. Even though when I was at University of New Hampshire, I work on the lattice on different cultivars. In some cultivars, addition in the nutrient solution give the better results, and in some cultivars, the foliar application give the better results. And the same thing I am observing here in my research program on fruit trees. Like we recently published a paper on the citrus. In two rootstocks, root application gave us the better results. And in one rootstock, foliar application followed by root application, like we call it hybrid application, provide us the better results. And the same thing we are observing in our field trial. The plants where we are applying the alternatively foliar and the root application, we are getting the better results. Application methods, you can apply in a different way in the soil application. If it's a solid material, mix it in the soil or dissolve in the water and apply it to the soil through sprinkler, drip, or overhead irrigation soil mixes. Now I know that there is already pre-mixed soil mixes are available, the substrates are available, or you can fertigate or foliar application. Seed priming, if you have a germination and emergence issues, then the dusting or soaking the solution, we call it the priming. Like make a solution of silicon, dip your cutting and seeds for a few hours, and then do the planting. You will have the better and uniform the germination and cutting treatments. If you are treating the cuttings, as I mentioned in case of petunia, and you will have the better root system and quick root formation and strong root architecture. Silicon application rates, it depends upon the product type and what percentage it has the monosalicylic acid application method and plant type. As I mentioned, it is a accumulator or non-accumulator. But I have tested from 25 parts per million to 1500 parts per million in citrus, lettuce, guava, mango, lantana, ornamentals, cabbage. So I haven't seen any phytotoxicity. So and not much of the reports are available in the literature like any phytotoxic effects of the silicon. But still, it's important to run small tests if you're going to apply. In general rule, if you're gonna apply the foliar application, 50 to 100 parts per million is sufficient. It's a good fertigation, 50 parts per million for regular fertigation and 100 parts per million once a week. If you wanna do the misting, 20 to 50 parts per million, soil amendment, 1 to 6 ton per acre, Volastonite or what source you are going to use. But one thing is very important in soil amendment, whenever you're going to add the silicon-based fertilizer, it enhance the pH. So you have to be considered that one and then decide to add the quantity in the soil mix. And the soilless substrate, it should have at least like 25 parts per million, then your plants will be getting the maximum benefit. As I mentioned, like a lot of silicon fertilizers and different blends, liquid and solid are available in the market. These are just you in the different names and just an example. There are some liquid blends and there are hundreds. I just mentioned few of them. And I think these the bottom two, which I have meant they have mentioned that these are also approved, OMRI approved to use in the organic production system. The important points, as I mentioned, it when you are add it, it may enhance the pH. So you have to be adjust the pH accordingly. Concentrated silicon solution, we avoid not to mix with other nutrients because it will precipitate them. And whenever you are going to use, always make the fresh solution. It doesn't mean you will, if you're going to be used 2 times in a month, you have to make you will just make one time. It's better to have the fresh solution. And whenever you are going to apply, agitate very well and mix very well. And silicon is always, and this is also an important thing. If silicon also, if whatever the source they are using, the potassium silicate or calcium silicate, so it means they're gonna add some amount of calcium and potassium. So you have to, especially in the hydroponic system, you have to be consider how much percentage of the silica, calcium and potassium, you're gonna be adding, so that you can quit it from the other nutrition program to make the balance. I'm gonna when just share some work, even though I put the UF logo, but the work I'm gonna share with you, it's done in my previous institution, University of New Hampshire, where I worked as a greenhouse and ornamental specialist. So we did some work. The main objective was for plant growth and development, post-production life, was to enhance the veg life, drought tolerance, and resistant to soil-borne diseases. So this is a study in which we done silicon in the drought tolerance, and it was. I'm very grateful to the Pleasant View Gardens in the New Hampshire who provided us the plants and for to do this study on the Petunia, lantana, and basil, and there is one more I'm missing. So, but I will share just some selected results. So it's a cyclamen in which the plants were 7 days after drought stress, there was no watering. So these plants, throughout the finishing, starting from their planting until the finished products, they were treated with the silicon. There was the control plants, 25 parts per million just foliar, 25 root application, then 50 root and foliar, and there was a last one in which low concentration, but as I mentioned, the term hybrid, like one time, suppose first week foliar and next week root application. So and these plants were applied with silicon through starting from planting to until the finished products when they are mature and ready to sale. And we stopped the irrigation. They were not watered for 7 days. And you can see the results. Control 25 parts per million. Control is almost, it's collapsed, but still it's 25 parts per million is almost dead, but as compared to control is better. But if you look here in the hybrid one, we just use 25 parts per million foliar followed by the root application. And the 50 parts per million root application, you can see the plants are the healthy. We did not observe much of the damaging effect of the drought or water holding. And when these plants were rewatered, they recovered very well. These three did not come back well. This is almost it's dead. It was dead. It was little bit okay. And but the best recovery, like these plants, like 50 parts per million root application and 25. And this is very impressive. Just lower dose, but as I mentioned, I'm following this question, but still for like what's the way, what's the reason, like why it's one thing what we have observed when we are adding the this approach foliar and followed by the root application, we are getting the more silicon accumulation. So I think that's the way it's more we are getting the better results. Same thing in case of Neogenia in patients, the Infinity White, the cultivars. So just finished products applied with the same, and just but in this case, just only after 3.5, 3.5 days, the control was dead. So that was basically we were just observing the control when control is gonna be dead. So just in 3.5 days, control is almost dead. Not the better, even 25 parts per million foliar and root not getting better. And still, if you will see that the 50 and 25 parts foliar. And the best results, in that case, best results were 50 parts per million. In the 21, the plants were okay, but still we had some the wilting symptom in the new in the leaves and in the flowers. But in the 50 parts per million, it was like a fantastic, and both on rewatering they recovered back without any damaging. Same was the situation in case of Lantana. Lantana survived like a control survived, like died completely at the day fourth of no watering. And in that case, still in these, we did not see the big difference between 50 parts per million foliar, root application, and combination of both. All these three can like perform very well and not a big difference. Yes, there was a difference in chlorophyll contents, like these had a more chlorophyll contents versus this one, but these did not not make well on the rewatering. So what we observed, like when in the especially in the lantana plants, so as I mentioned, like we did not see any significant difference in the growth on the under drought conditions, and we did some chlorophyll contents like using the spad meter leaf greenness. It is a difference control, and it is after 4 days after drought, and you can see that in the control it because the plants were almost like a dead. We did not have any the big numbers, but the last two treatments where we apply the root application 50 parts per million and lower concentration, but the hybrid mode. So both were like not a statistically not a difference, and then followed by the 50 parts per application as a foliar. We also did with one of our grower, but we did some work on cut flowers. So in cut flower, they are having some issues in the stem bendings and thin stems. It's a snapdragons. So we applied the plants with 50 parts per million foliar weekly application, and there was an increase in the reduction in the bending. You can and more thickness. You can see is here is the control that they are on the base they are more thin, and but when we applied the plants were more lush green and more healthier, and there's an increase in the stem diameter, and that's the reason they had a they had a less lodging, less bending. The reason behind this bending is that so this is not this is just an example to show you done by the Mandlik. So they apply the plants with the silicon, and this is the control, and this is 1 millimole of silicon on daily basis, and all the red spot that you observe, it's a silicon accumulation. So this is the way how when plants uptake, it is accumulated around the cell walls and provides the mechanical strength. And that's factor has been we are very well observing here in Florida, because it's our now third year, and you know that in living in Florida, we are having the hurricanes, which is a big damaging effect to our fruit crops and the fruit drop. So in the silicon treated plants, even though we had a back-to-back hurricanes in 2024, there was a fruit drop, there was a limb breakage, but it was really significantly less as compared to the non-silicon treated plants. So I'm talking about my 3 years. We are applying to these plants to silicon more. It's up to 3 years. So this is the one of the mechanism. This is another thing we have observed, like the florets, the length of the florets is more, and all the florets are opening at the same time versus the control. We can control it starting from the base and still unopened, but what I observed in the silicon treated plants, they are more, there is a more longer, and there is a all are opening at the same time. So the key points, the silicon is effective in improving the drought tolerance and resistance, especially in lodging in selected ornamental plant species which we tested. Overall low level of silicon applied as followed by the drenching found to be more effective. As I mentioned, the 50 parts per million foliar and the 25 parts per million applying foliar and root application gave us the both the good results. But overall, based on my work on Snapdragon and work on Lantana, Petunia, basil. So we have found that especially in these plant species, if you are applying the low concentration, but the hybrid application, alternatively root and the foliar, you will be getting the better results. So, and the overall finding is that definitely, as I shown you, that the silicon application helped to enhance the drought tolerance. So this improvement in drought tolerance is associated with high relative water content. There was a more water holding capacity within the tissues, there was a more chlorophyll contents, and there was a more accumulation of osmolytes and the formation of reactive oxygen species. Because whenever plants are coming under stress, there is an increase in the reactive oxygen molecules with attack with the cell membranes and damage the cells, and you will have the browning symptoms and leaf drop and the death of the plants. So that's a mechanism is associated with the silicon to improving the drought tolerance and inducing the drought tolerance. So, and silicon also, we did some post production life effect of silicon on post production life, and it was also found to be very effective to enhance the post production life in some selected ornamental species. The same Neogenia impatiens. So, post production life mean once the plants were treated with these different concentrations, 25 and 50 parts per million applied foliar and root application, once plants were ready to finish the finished products, they are ready to sell to the consumer. We put them aside and just give them the irrigation, but no fertilizer for 15 days. So after 15 days, what we observed, like a control plants versus the silicon treated, they were at the same, and there was not much of the further growth, even though we observed some like a wilting symptoms, some curly leaves on the bottoms, and also that kind of observed we in 25 parts per million. But better post production, like more healthier, and even though increase in the number of flowers we observed in the last two, 50 parts per million and 25 parts per million. And similar was the results in case of petunia we observed. You can see that here, like after for 15 days, just 100% irrigation, no fertilizer. Still, we were having some drying branches over here, like browning here in, but like and no much flowering or stem growth. But in silicon treated, they continue to produce the flowers, and we have observed the more like a number of flowers and more growth just on the watering. So it means that it's helping. It's kind of acting as a growth promoter when in the absence of any fertilizer application. Similar results in case of lantana. Not a big differences we observed in these last three, but overall we observed the 25 parts per million applied alternatively is the best. But here you can see that in the control plants, and even though 25 parts per million silicon, we are observing the tip burning and browning symptoms for 15 days when they were just no fertilizer and water application. So what we observed, like in case of leaf greenness, when we take the data on the using the chlorophyll meter, so we observed that the plants which were treated with the hybrid application in low concentration, they had the maximum leaf greenness, and that's a reason we have seen that these Like these are the 25 parts per million is giving the better growth and the more flowering. And followed by, we did not see any big difference between the 50 parts per million foliar application or the root application. And here is the control was the minimum one. And when we remove the plants out of the pots and to see what's actually happened with the roots, so you can see the difference. This is the control, Bitonia, Lantana, and knee union patients. So if you will compare the silicon treatments as with control, there is an increase in the roots. There is a more roots, and you can clearly see that. And especially in case of knee union patients, almost not much of the roots, and you can see the roots. And if you will compare between the treatments, you can see that the first like a 50 parts per million root application and 25 parts per million root and like a foliar application. And so here you can see that in case of Petunia, how much is the more roots, and same, and in case of like Lantana and New Guinean patients. So this is a clear indication, and it's impact on the root architecture. And that's the reason they are holding the more water. They are facilitating the more nutrient and water uptake and pour it into the plants. So the key points of this research on post-production, it is very helpful and to strengthen the root architecture and improved water and nutrient uptake, resulting in the high relative water contents, and that's the reason. And they survive the droughted conditions. They help to maintain the turgidity of the cells, and due to the more production of the osmolytes, and keep them fresh and alive. Enhance chlorophyll contents, which helps more photosynthetic activity and high concentration of osmolytes. Like osmolytes are the compounds within the plants which help them to tackle that kind of like stresses, heat, cold. So it indicates that it is all these factors, the improvement in relative water contents, more chlorophyll contents, and strength, more formation of roots. It helped to improve the post-production life of these selected ornamental plants. So thank you very much, and I think I'm in time and happy to take any questions.
All right. That was fantastic, Mohammed. Thank you. Let's see. I would leave your presentation up just in case there's questions regarding
Okay.
your presentation, but we do have several questions. There's one that I want to start with, though, that somebody put in chat, and if you could explain what lodging is.
Okay. Could you explain why lodging is? So lodging is so the bending, and then suppose if there is any once they reach to to certain height, they fell down. So and they bend. So this is that's we call it the lodging.
All right. And then there's another question in the chat, and then there's a few questions in the Q&A. So if you want to
Okay.
start with the chat and just read the question aloud and go
Okay.
ahead and provide your answer.
Okay. So okay, the question is from by Amir Kado. Sorry if I'm not pronouncing well. So the question is, what sources of silicon are the best bang for the buck, most efficient for productivity versus cost? So that's a very good question. And to be honest, like I I could not recommend, like, but I would just say we haven't done any. We are working on the cost effectiveness in the citrus. Economist is involved with us, but one thing is very important. Regardless, is the vegetable producer or ornamental producer, even though from the fruit producer, they call me and they said, Mohammed, I'm using silicon product, and it's been a one season. I did not see any impact. So then my follow-up question would be can you please share me the label of the product? So when I looked at the label, so it says 58% silicon. So and when you go to the more deeper, so it's a silicon dioxide. The problem is that whatever is the product I want you're gonna be choose, make sure you are gonna be not by the silicon dioxide. The reason is that silicon dioxide is not the form which plant can maximum uptake, and you can get benefit of the silicon. So it's similar like in Florida, living in Florida, we have silicon dioxide in 90% of our soil, but it's not the form which plants can uptake. It's the same way you are in the ocean, but you don't have drinking water. So if you're gonna choose the silicon product, the first thing, don't be like you have to go to the percentage of silicon. You have to be asked the question to your vendor or your what who is providing you, what is the water soluble silicon, which is the monosalicylic acid. Let me know the percentage of that one. So having the silicon dioxide 58%, it's better to have the 8% of monosalicylic acid, and you will be getting them better results. But about the cost effectiveness, I sorry, I haven't done. Maybe yeah, Neil Madsen, he is working. He has maybe done some cost effectiveness, and he would be better to answer this to your question about cost effectiveness. But I would say selecting the product is more important. Just go to the water soluble concentrate, that is the monosalicylic acid, or we call it MSA. So lodging and yeah, I don't see any other question, Meena.
There's questions in the Q&A.
Oh, Q&A. Okay,
Yeah,
okay.
there's I see 7 questions in the Q&A.
Okay. So how to go to Q&A?
And it, it looks like attendees have also commented, which is wonderful, but you can go
Okay.
ahead and
Okay, okay, got it.
answer all the questions as
I
well.
got it. Parboiled rice. Yes, can parboiled rice hulls incorporated in the media or as a mulch provide the silicon to benefit plant? Yes, that's a very good question. And basically, I'm from Pakistan and belong to agriculture family, and we have a lot of the rice area. And the way we are using initially that we are doing the rice husk, and then we start making the biochar of the rice husk, and it is providing a good source of silicon to the soil, and we have seen a very good improvement in the soil microbial activity. Uh, yes, yeah, yes, but the release rate of plant bioavailable silicon, definitely it varies from like a tire feedstock, and even though that's why this is the best form if you are using the biochar of selective like a rice husk, or bamboo sticks, or muscanthus grass. As the second most abundant element in the earth crust, it is possible to account for ambient silicon in the experiment. What level of silicon? No, as I mentioned, that's not a form that plants can uptake. Uh, okay. When the question is that when adding silicon to a final dilution fertilizer solution, would you recommend dissolving the fertilizer first and then adding silicon and vice versa? Yes, so as I mentioned, there are some good products are available. Like even I'm working with the SoluSil, so you can first unit dilute the solution, and then you dilute the silicon. Then we that it's not going to be like impact, you will not have any precipitations. So, but you are not mixing the two stock solution together, but you first dilute one. So what form of silica was being used in the stress test for impatiens and cyclamen? So basically for this study, I used the silicon source. It's the company Dynagrow. They provided me that product, and I used that product in that stress the post production and stress studies. Which type of silicon is used in the foliar and drenching research? So that's the blended the liquid product by the Dynagrow, and I think its name is Protect. So I used that one by that time in that study. Michelle and Emma, would you suggest silicon as an alternative to conventional fertilizer or best used in conjunction with? Yes, we have I did not mention here in this talk, but I also have done work on the lattice, and we just reduced not a much, but we just reduced the nitrogen concentration like 100 parts, 150 parts per million. We put it as a control, and then we reduced 120 parts per million plus addition of silicon. We did not see the big differences in the head size and the growth. So, but it's not 100% you will skip the NPK and you are not just adding silicon. Yes, if you are using it in combination, and you will have the better synergistic effect. Peter, at what point production was the silicon applied for the test? So just starting once the growers, because it was there was a nice collaborating growers and the greenhouse growers. in New Hampshire. So once they have the planting has been done, and then the weekly basis we start applying until the finished product. Do you know of any testing that has been done in regards of any specific perennials? That's a good question. Actually, when I was there, I missed the name. There was a one of the nursery who is doing the perennials, and they were interested in, but I left the position. But so far, I don't know. So any research has been done on the perennial. Maybe Neil Madsen. It's a good question to Neil Madsen or Jennifer. They can give you the better answer about that. If you have mixed plant material, can one formula work? So, yes, in general, it is beneficial if you are really using a good source and monosalicylic acid, which is the plant uptake form. You can, for the safe side, as I mentioned, 50 to 100 parts per million, you can apply. Then yeah, it's you will feel you will have the results. Just and the one question that grower asked me, what type of the first effect we will see? You will see your plants are looking even more like a healthier. They are more green as compared to the perennial plants and fruit trees, especially in case of the vegetables and the ornamental. You will see the results more quick. Uh, okay. Yeah, I think there's no more question.
Well, I have some questions for you, Mohammed, just
Okay.
from my own curiosity.
Mhm.
From one of your first slides, you had that citrus trial where you showed drought resistance, or no, it was frost protection, I think.
But yes, cold tolerance.
This may seem like a silly question, but did you only do a foliar application in order to provide that silicon buildup of the leaves, or could you do drench? Like what was
That's
your method?
that's a good question. So I think you were talking about.
Yeah, it was way at the beginning of your presentation.
Yes. So you are talking about this one. Yeah. So this one is the picture I showed you. So in this one,
Yeah,
it's
just so you know, we can't see it anymore, but
oh, okay, okay.
yeah.
So in that trial, we are using uh, foliar application, we are using the root application, and we are using the combination of both. We have after 2 week application, and we have after 4 week application. So in this study, what we have observed, there is not a big difference so far. We observed the foliar application bi-weekly, like after 2 weeks, and the combination of foliar and root application after a month. Both are on the equal.
Oh, interesting.
So yeah, so that's the difference. And but the overall in the results in the plant performance, we did not see the big difference. Yes, back to your question. For the picture which I shown, the best one was the foliar application, 100 parts per million after every 15 days, like after 2 weeks.
After 2 weeks.
After
Okay.
2 weeks, yes.
So that kind of goes into my next question. If folks wanted to do their own tests in their greenhouse,
Mhm.
with their whatever cultivars or what have you, how long do they need to conduct these trials? Like, is it just 1 month that they need to kind of conduct the test? What would you recommend?
For the ornamentals, like for the flowering plants, as I mentioned, very quickly they will see the results, depending upon the season of the crop. And what I have observed, starting from the planting and until the finished product, we have seen the results. Okay, the clear differences are coming out. And but in case of citrus or even the some woody perennials, it takes time. Maybe in the first year you will not see the big differences, and because we have to build that level. And I haven't done that question here, but when every year I give a lot of silicon talks, there is a one common question. Okay, so what is the level we need to build in the leaves? Like if I'm going to applying the silicon to the plants, and in case of nitrogen, I pull the samples, I send to the labs and water labs or other nutrition labs, and they will send me the report, okay, and let me know, okay, your nitrogen is 2%, it's deficient or it's sufficient, and what's the criteria for this one? So yes, we are developing the criteria for citrus, and we are in the third year, and so far we know that if the level of the silicon percentage is built up in the range of 2.75 to 3%, you are getting the maximum results. And that's the growers are also observing. But in case of ornamentals, I don't know, maybe the nail can mention that, and I haven't done this because these things need to do. What is the level we need to build up? Because it's all about the level, how much level we need to build, so that we can have, okay, it is do we need to add more or no, or we are applying the extra.
Okay, what is the level of silicon within the leaf?
Exactly. What's the level
Okay,
of silicon in the tissues?
all right.
Yeah.
And I've never tested that with the tissue test. Can you
Yes,
get
the
that
no,
done?
no,
Okay, all
yes,
right.
yes, no, no, you can done. Yes, the labs, there are some selective labs which can do this analysis.
Um, okay, I have a few more questions and we have time, so I'm gonna ask away.
Yeah. Oh,
Um, well, I guess I have one more question. So you had mentioned that silicon soil amendments enhances pH. Could you explain that a little bit further? What do you mean by that?
so basically the way they are, especially the conventional one, and I think that's the Sean will also mention in his talk why the his product is different and not gonna be a. So normally the products which are mixing the lye, so there is a lot of sodium hydroxide they mix, and which cause like a when you add it, it's already having on the high pH, and when you are added in the soil, it will enhance the more pH of your soil. So it's more towards most of the blends are towards the more higher pH side.
Okay, interesting. All right,
Yeah.
that's really interesting. It looks like we have another question, two more questions,
Okay.
three more questions, I think. So if you want to look at the Q&A.
Okay. Let me go to the Q&A.
I think it starts with Gerarda. Are all forms of silicon capable of a drench and foliar?
What are the best labs to test the silicon that you have to be used? If you have incorporated silicon into soil, do you still need? So the question is that if you have mixed permitting. Are all forms of silicon capable of drenching and foliar? Yes, if you have the liquid blend and which is the water soluble, then either way you can use it like as a root application and foliar application. And we are running a big citrus trials, and each site it is a 32 acres, and one like a foliar application site is 8 acres, and we are injecting through the injectors from the main irrigation line. And what's the next question? If you incorporate the silicon into the soil, do you still need to add drench or foliar application? We grow flowers for cuttings. Uh, yeah, if you have incorporated in the soil, so you don't need to the drench it. Yeah, but if you have a foliar application, as I mentioned, and based on my experience on the peaches, on the citrus, in the lettuce, in some species root application, even though as I mentioned in the lantana and petunia, in some cultivars and species, more root application perfect well. And mostly we have observed that the plants, when they applied with the root and foliar application, they give the better results. So I believe if your soil in silicon is incorporated in the soil and you have some foliar application, you will have the better results.